Okay, so let's start with the topic trigonometry.
Okay.
So let us understand what does this word mean. It is actually
Triangles.
triangles, but it's a combination of trigonon plus metry. These are Greek words. Trigonon means triangle. Metry means measure. So we deal with triangle measures. So triangle measures means there are two aspects. One is with the angles, other is with the sides. So the correlation between angles and sides of a triangle. This is
Okay.
what it is called trigonometry. So in trigonometry, also we there are two classifications. Trigonometry with right triangles
Okay.
and trigonometry with non-right triangles.
Triangles.
Non-right means like obtuse,
Okay.
like that. So there are separate set of strategies when you are dealing with right triangles and non-right triangles. As the chapter goes on, we'll go in detail. For now, we'll focus on the basic aspects like prerequisites, like similarity versus congruence. Did you ever come across these terms before?
I do, but I don't really remember. Oh, we did, but it's in my notebook.
Well, it's not about if it is in the notebook, whether if it is in the brain. Do you remember it?
No.
Congruency means you can think it of as same objects, identical objects.
Okay.
It's like if I show you an A4 size paper and if you also randomly bring an A4 size paper, if you put them one over the other, they will be the same, right? Do you understand?
Yeah.
So that is called congruence. Congruence means ditto, identical objects,
Okay.
same objects. So if placed one over the other, they overlap. Any doubt?
No.
This overlapping feature is called, we also call it as superimposable. So if you put one over the other and if they match, they are
Okay.
superimposable.
Okay.
So this is what the concept is about congruence. Similarity means, I mean similar. It's a if there is a triangle like this, but if I zoom in or zoom out, let's say zoom in, it will become bigger, right?
Yeah.
The same object, but bigger. It's almost like zoom in. So bigger triangle, or if you zoom out the outer one, you'll get the inner one.
Okay.
So the object is same. The scaling is different. It's like using a camera. You are zooming and zooming out the same object, but the size only different. Size is different. So that is
Okay.
called similarity. So to study similarity, we need to understand the concept of zooming in and zooming out. In the camera, you might have seen the numbers 1x, 2x, 3x, right?
Yeah.
These are zoom in or out.
In.
In. You might have also seen 0.5x.
Yes, that's zoom out.
zoom out. So these are the things. So some basic concepts which we need to keep in mind is, scroll down. If two triangles are similar, then can I say, let's say if it is this angle is 30 degrees, can I also call this angle is also 30 degrees?
Yeah.
So that is a concept. Main thing is, if it is let's say 60 degrees, this will also be 60.
Mm-hmm.
So main thing is, there are criteria. A means A stands for angle, and angle criteria. So if any two triangles, any two triangles, if you compare the angles and you get, and if you notice that two angles are same, if two angles are same, then we can clearly say that triangles are similar, or you can say similar triangles. It's the same thing. So to identify whether two random triangles are similar or not, we have to look at angles.
Okay.
So let us say there are two triangles. It is given that this angle is 75 degrees and this angle is 30 degrees. This is also 75 degrees. This is 105 degrees. Question is, are these two triangles similar?
No.
Okay. Okay, if not, then how? I will
Mm.
explain why. Why not?
Well, 105 plus 175 is 180, so you don't even have the other angle.
Okay, okay.
And
Okay,
even
okay,
if I
let's
move the triangles around, 30 and 75 don't really match up on each side.
okay, let's change this angle a bit. Let's say this is 60 degrees, and let's say this is 45 degrees. Are the triangles similar? Same question. Are the triangles similar?
Similar meaning the side of the angles on each side are the same, right?
Yeah, compare them.
So like these two would have to be the same, and the other two would have to be the same.
Okay, did you already find one equal angles? One pair?
Of like the missing angle?
First compare these two triangles. Do you see any common angle between these two?
Yeah, 75 degrees.
75 degrees, 75 degrees. So 1A
Yeah.
is, we obtained that. If by chance we get one more angle, we can say that it is similar.
Oh, so the missing angle here is 60,
60.
and the missing angle here is 45. So yeah, similar triangles.
Yeah, that is the point. So this is 60. So this matches with this. So another angle,
Yeah.
another capital A is found. So
Mm-hmm.
one angle is 60 degrees, one angle is 45 degrees. So minimum AA. People sometimes call it as AAA. AAA is like finding three angles. That is a bit hassle. So the minimum requirement is, you can stop
Okay.
at two angles. Double A is fine. So therefore, 45 degrees and 60 degrees conveys that triangles are similar. So these are some questions to identify similar triangles. Hmm. Yeah. So when it comes to similarity, scroll down. There is one more
Mm-hmm.
point which is important. Similarity statement. Statement means, how do we write that? We always don't draw the diagram and say these two triangles are similar. We have to write it in terms of alphabet. We write it like this. It's triangle ABC. Let's say it is triangle to another triangle DEF or LMN PQR. So it's like diagrammatically it's like this ABC PQR. If we found they are similar, we have to write like this.
Okay.
And the order in which we are going to write is important. Whether it is PQR or QPR, triangle QPR, it is the same thing. But
Yeah.
how we are going to write these alphabets is is an important aspect. So I am writing here order is important. Order in which we are going to write.
So the same order I do on the first triangle, I have to go on the second triangle.
Yeah. So let's say we consider the previous example. What was that? 75, 45, 60. Let's say this is 75, this is 45, this is 60. Let's say this is 45, this is 75, and this is 60. Can you
Oh,
try what is the
so the
similarity
first one
statement?
would be, does it go from like lowest to highest?
Well, there is no particular order. It's just that if you write something, the other side should match it.
So angle A is equal to angle Q.
So A
So
corresponds
my
to Q.
so my first would be A and Q,
So you
and
have to write
then
it like this. First step is simple. Yeah, you can write triangle ABC on the left.
okay. If I did triangle ABCD on the left, then it would be triangle Q. Sorry, yeah, triangle Q, triangle QRP.
B corresponds to R, right?
Yeah.
So BR, QRP. So you have to write like this. So triangle ABC is similar to. This is the symbol.
Okay.
Okay.
And if it's not similar, does there a line through it?
I mean, you can write is not similar.
Okay.
So if you write like this is equal to.
Okay.
And if you write like this is similar to. Okay.
Okay.
And if you write like this is called is congruent to. Congruent means
Yeah.
same objects. So yeah. So the order in which you are going to write is important because A corresponds to Q. So therefore, angle A is angle Q, angle B is angle
R
hmm, C is
E.
hmm. So this is about similarity basics. So so to identify if triangles are similar, we can check two angles, correct?
Yeah.
So what if the angles are not given? What if sides are given? how do we check with sides? Sides means, let's say if triangle ABC is similar to triangle, let's say QRP. There is a way to do this.
So to convert the side into angle or just go off the sides?
We don't convert sides into angles. They are different
So we
things.
just go off the sides. Okay.
If sides are given, how do we determine triangles are similar?
The same way we did for angles, but using sides.
Well, in the previous case, angles are given. There is a criteria, AA criteria. But for sides, it is a bit different. Sides, how we are going to do that is, let's say if two triangles are similar like this, let's consider the left one. The sides are AB, BC and AC, right?
Yeah.
So AB, BC, AC. AB corresponds to what side on the right?
R. QR.
QR, right?
Yes.
So you have to write like this, QR, and BC corresponds to
R. R. P.
and CA, AC.
Q. P.
So the thing is, you have to do like this division. So the sides follow this
Oh
ratio.
yeah, he gave us this formula.
So the sides follow this ratio compatibility.
Okay.
So basically, ratio of corresponding sides. Corresponding sides means AB corresponds to QR. So ratio of corresponding sides, I'm writing as corresponding sides are equal. The ratio should be equal. Okay.
Okay.
So this is how we test the sides. And earlier case we discussed how we test the angles. So that is the thing. And then there is a good question in the textbook, but this is a bit advanced. Let's try it. Okay, let's say this is a right triangle like this.
Mm-hmm.
From the vertex, let's say we are dropping a perpendicular altitude. So let's say A, B, C, and D. How many triangles do you see in this picture?
Two.
Which one is it?
A B D and A D C.
ABD and ADC.
Yeah.
Are there only two?
Yeah.
There's actually one more. Can you guess?
Like using a line that's given.
It's not like line, but entire overall figure. How many
Oh, A
triangles?
B C A B C.
Hmm. This one, and the larger one.
Yeah.
So how many triangles is three? So there are, let's say, triangle ABD, ADC, ABC, right?
Yeah.
Okay. The thing is, whenever you drop a perpendicular from 90 degrees,
Mm-hmm.
from the 90-degree angle, if you drop a altitude, all the triangles that you see, left, right, and the bigger one, are all similar to each other. Try to remember this.
Okay.
Are all similar. Let us understand why. Okay. Okay. Let's say this angle is x degrees. Okay.
Mm-hmm.
How much will be this angle?
It wouldn't be x degrees because B should be as similar as AD. Uh, would it be x too?
It's not x. The thing is, try to look at this bigger triangle. This angle is 90 degrees, right?
Yeah.
If this is 90, if this is x, the third one will be how much? Try to find in terms of x.
So if we're considering ABC triangle,
I mean, that is a hint. ABC triangle, x plus 90 plus angle C is how much?
180.
So angle C is how much? We'll get the answer as something like this, 90 minus x. Okay.
Okay.
So this is one concept. The thing is, if in a right triangle, the sum of these two angles, which you are seeing, the sum of these two small angles should add up to 180 90 degrees.
Okay.
Let's say if it is 15 degrees, how much will be directly? This one,
15.
this
The two red ones?
one red below is 15 degrees. How much will be the top angle?
The same, right?
See, they add up to 90 degrees,
Oh,
okay?
they add up to a 90, so 75.
75. So without doing this calculation, this plus this is equal to 180 degrees and doing the calculations, this is a shortcut.
Okay.
So the theory is sum of acute angles in the right triangle. Sum of small angles in the right triangle add up to 90 degrees. Okay, let's say
Okay.
this is 1.1 degree. How much will be the top one?
89.9.
And 88.9. Okay.
Oh,
So this is the trick. They add up to 180. So anyways, let's say if it is x. So this angle will be how much now?
X.
So this is 90. This is x.
Which one's 90? Oh, the
This
top one.
focus on the bigger triangle. So one angle is x. Other one will be
90?
90 minus x. We found it here. 90 minus x.
Yeah.
So that is the thing. So let's draw them individually. Scroll down. So this was the left triangle. This was the right triangle. And the bigger one was like this. Okay. So let's label the vertices as well. This is A, B, D. This is A, D, C. And this is A, B, C. So let's say this is x degrees, okay?
Mm-hmm.
How much was angle D here? Can you look at the diagram?
90 degrees.
90 degrees. This one was also 90. Can you guess how much will be this angle?
90 minus X.
90 minus x. So 90 minus x. Okay. And how much was this angle C? Do you remember?
Mm-hmm.
In the diagram, look at the diagram. How much was C?
90 minus X.
90 minus x. So if you compare these two triangles, did you notice something?
They're similar.
Because
They have the same type of angles.
two angles are already matching. So similar. So two triangles are already similar. And what about this large triangle? Is it also similar to these two? How do we know?
because B and C is also 90 minus X.
B is how much?
X.
C was 90 minus x, right?
Yeah, so it's similar, I guess.
So all three are similar to each other. This is the thing. So when an altitude is dropped from 90 degrees, 90-degree angle of right triangle, read this carefully. Altitude dropped from 90-degree angle. It's like, let's say the triangle is like this, 90 degrees here. If I drop altitude means
Straight down, like the height of the triangle.
like this. So when you split like this and this, they are all
The same, similar.
similar. This is the concept. So anyway, that is the thing. So this is about angles. This is how we are studying angles. Let's say, let's consider the question from the textbook. A triangle is like this, and altitude is dropped like this. We don't know if this angle is 90 degrees. It is not
Okay.
mentioned in the question. But this time the data is given as this is K and L. Let's say this is 6.7 meters, 3, 13.4, and 12. How do
What's
we
the variable here?
J? Okay. So question is same. Find any triangles with if they are similar.
JKM is similar to JML and JKL.
Okay, why is that?
Oh, but there is no 90 degrees.
Hmm. So we cannot really compare the angles this time. What is the alternative
Yeah,
then?
actually looking at the angles.
Well, angles aren't reliable this time. In this case, so the alternative is another alternative is to judge from what?
Sides.
Sides. Yes, sides. What condition did we learn regarding sides for similar triangles? They must follow a
Wait,
specific condition.
what two triangles are we looking at?
Okay, let's say these two triangles, left and right. These two.
So JK is similar to JL.
Yeah, how do we know that? Okay. Are they following any side ratios?
The sides, like the measurements.
Well, think of it this way. This one. and this one. It's like times 2.
Okay.
But this one is not times 2.
Times 2.
So we don't really know. And the third side is same. So all the sides are not following a ratio. So we cannot just directly tell that they are similar.
Mm-hmm.
So let's do one more question. Let's say there are two triangles. Side lengths are given 1.8, 5.4, 7.5 and 9.0. How do we judge if the triangles are similar?
Using the angles?
Look at this data. Angles, is it given?
No.
But what is given?
The sides. The side lengths.
So how do we use side?
So A and C would have to be similar to DF.
Okay. Yeah, AC, DF. I mean, you can see it, right? 1.8, 5.4 means 3 times.
Yeah.
3 to 9 means 3 times. Here to here means 3 times. So triangles are similar, correct?
Yeah.
So basically, you can say 5.4 upon 1.8 is equal to 3, and 9 upon 3 is equal to 3,
3.
and then 7.5 upon 2.5 is also 3.
3.
So all these three ratios are equal. So triangles are similar.
Okay.
These are the common methods. So, that is about 7.1.
Okay.
7.2 is about use similar triangles to solve problems. Okay, what problems? Oh, so let us say there are two triangles like this. This is 9.3 meters. Let's say this is 8.4 meters. This is 24 meters. They are asking to find this missing side x.
So I would use that formula.
They haven't given anything else, anything yet. They didn't tell. They didn't specifically mention that they are similar, but they are asking us to find x value.
I can do 8.4 over x equals 9.3 over 24, cross multiply and then divide with 4x.
See, we don't. I mean, to do this, before we have to confirm the triangles are similar or not.
Okay.
So before this, how do we confirm that?
To see if the angles are all similar.
Can you try it? Can you try to prove it?
Well, there's a right angle, so if I draw a straight line down, one angle would be x and the other would be 90 minus x, and the same on the other side.
On the other side, how it will be? I mean, on the other side, one angle is 90 degree. That is common. Okay, one A we got
Yeah.
90
And the
degrees.
other side is also 90 degrees.
Yeah, that is one A, right?
Yeah.
One angle which is common in both. That is fine. So we
Okay.
got one A. We need one more A, right?
X, because both the sides are missing.
Which
It could be this, or this, or this, or this.
okay, we don't know if this angle is equal to this one. Maybe if it is flipped like that, we don't know, right? So how do we determine that? Which angle is equal to which angle?
These two angles equal to 90.
They add up to 90.
Yeah.
So similar. AA criteria means we already got one A, 90 degrees. Can we find one more A? That is a question.
I guess not.
Well, there are some concepts regarding lines and angles. Hmm. You know this vertical angles, corresponding angles,
No.
alternate interior.
No.
Okay, so some basic concepts are when two lines intersect, the angles which are opposite to each other are equal. Okay, these are called vertical angles or vertically opposite angles. Vertically opposite angles, they are equal. Vertically opposite angles are equal. Any two lines, wherever they intersect, the angles which are facing each other, this one, are equal. And
Okay.
this angle and this angle, which are facing each other, are also equal.
Okay.
So in the question, do you see any familiar angles?
This one and this one, and that one and that one.
Yeah, so basically these two lines are intersecting, right?
Yeah.
At this point of intersection, these angles are facing each other. So they are equal. So that is how we get one more A. This. Okay.
Okay.
So
Yeah.
I'm mentioning this as the other A is vertical angle.
Okay.
So by A criteria, we say that triangles are similar. Okay.
Mhm.
So let's say this is A, B, C, D, and E. So can you write the similarity statement?
ABC is similar to E,
Triangle ABC
D,
similar to triangle.
EDC.
Okay. E, D, C. That is correct. Okay.
Yeah.
From after writing this only, you have to write AB upon ED
Okay.
is equal to BC upon DC like that.
And then AC over EC.
Hmm. Yeah, after writing that formula, you'll get something like this. You have to cross multiply like this to get X value.
Yeah.
So this is the process. So I'll stop the class here.
Okay.